Let us see two more problems in sequence networks. Okay, see here in this problem, the three identical star connected resistors of 1 per unit are connected to an unbalanced three-phase supply. The load neutral is isolated. The symmetrical component of the line voltages are x theta 1 y theta 2. If all the per unit calculations are with respect to base values, the phase to neutral sequence voltages are. Okay, so for example, let me think of positive sequence, negative sequence voltages. This is going to be VA1, positive sequence. So it should be, phase sequence should be ABC. So if I sit here, first A will go and after that B should go. So this should be VB1 and this should be VC2. Oh sorry, VC1. Okay, now let us think of negative phase sequence. For example, this is VA2. Okay, and here this should be VC2 and this is going to be VB2. Okay, so let me calculate line voltages. So VAB1. Okay, so AB1. So with respect to B, how much is A voltage? Okay, so with respect to B, normally in our network theory also, if I write VXY, what does it mean? With respect to Y, how much is the voltage of Vx? So with respect to B, how much is the voltage? With respect to B in the sense VA minus VB. So this is going to be V minus B1. So this is going to be VAB1. Okay, and here if I see VAB2, A is here with respect to B, how much is A? So B should be negated, minus VB2. So this is going to be VAB2. Okay, now with respect to this, with respect to VA1, okay, my line voltage should lead by 30 degrees in positive sequence, and in negative sequence the line voltages lag behind phase voltages. Okay, actually this is the rule normally we discuss in network theory, but anyway, see here with respect to VAB1, VAB1 is x at theta 1, means that how much is VA1 or VAN with respect to neutral? 30 degrees lag. Okay, so means if x is theta 1, if x is theta 1, what do you say, line voltage, phase voltage will be same as x theta 1 minus 30, so it's going to be this. Okay, and you see here if I see, okay, so VA2, this is going to be VAB2, so with respect to phase voltage, line voltage will lag behind. Okay, or with respect to line voltage, my phase voltage will be leading by 30 degrees. So okay, here we have to discuss one more thing about line voltage, phase voltage. For example, in star connected, okay, so for example this is star connected, for example star connected alternator. Okay, so this alternator rated voltage is 11 kV. Okay, how much will be the phase voltage? Is going to be 11 kV by root 3. Okay, now if I consider base voltage or in per unit, okay, so this is actually very important because some people feel by root 3 will come, by root 3 will come because it is the given voltages are line voltages, so in converting into phase divided by root 3 should come, no, or into root 3, whatever it may be, root 3 concept will not come in per unit, because if it is 11 kV, it will be 11 kV by root 3. For example, if alternator is working at rated voltage, rated voltage is how much for the line? 11 kV will be the rated voltage for line. Okay, and how much will be the rated voltage per phase? 11 kV by root 3. 11 kV by root 3 is the rated voltage. For example, if I say my alternator is producing rated voltages. So rated voltages in per unit, how much it will be? 11 kV is the rated voltage, it is producing 11 kV. So how much is per unit? 1 per unit. Now, if I come to here 11 kV by root 3, what is the rated voltage or base voltage for that? It is going to be 11 kV by root 3 only. So if it is 1 per unit, it also will become 1 per unit only. Okay, for example, if line current is 100 amperes rated, okay, so let me think of delta connected, then you will get better clarity. So for example, this is delta. Okay, so in delta, for example, line current is 100 amperes, which is rated value, is going to be 1 per unit. Okay, now for example, if this is rated, in the sense fully loaded, my phase also will be fully loaded or not. Now how much will be my phase full load current? 100 by root 3. Okay, so if my line is at rated conditions of current, phase also is at rated conditions of current. So line is 1 per unit, means that phase also will be 1 per unit only. You have to focus on this point. Okay, now let us think of the another question, that is a three-phase alternator generating unbalanced voltage is connected to a balanced load through a three-phase transmission line. The neutral of the alternator of the Y point of the load are solidly grounded. The phase voltage of the alternators A they have given, EB they have given, EC they have given. The positive sequence component of the load current is. Okay, so positive sequence component of the load current means that normally R phase or A phase will be the reference. Okay, so he is asking IA1. Okay, what are the things they have given? A, EB, EC they have given, and impedances they have given. So let us calculate IA. IA is going to be how much? A divided by this plus this, that is going to be J2. So how much is EA given? 10 at an angle 0. So 10 divided by J2 is going to minus J5. Okay, now let me calculate IB. IB is going to be how much? EB by ZB. EB they have given 10 at an angle minus 90. So minus J10 divided by J3 is going to be minus 3.33. And let me calculate IC. Okay, so if I calculate IC, how much is EC given? 10 at an angle 120. So 10 at an angle 120 divided by J4. Okay, so J4, so this is going to be 10 divided by 4 is going to be 2.5 at an angle 120 minus J is going to minus 90. 120 minus 90 is going to plus 30. Okay, now let us calculate IA1. Okay, so think of the matrix A inverse. So IA1 is going to be 1/3 of IA. Okay, IA plus alpha IB plus alpha square IC. Okay, so this is going to be 1/3 of IA minus J5 plus IB minus 3.33 alpha at an angle 120 plus IC 2.5 at an angle 30. 30 plus 240 is going to be alpha square. 240 is going to be 270. Okay, so if you calculate, you are going to get 3.51 at an angle minus 81. Okay, so in this way we are going to solve.